Welcome to solverfy.
(23.120). We have this configuration of resistors here. First, we want to find the equivalent resistance between points A and B. Then we want to imagine connecting 24 volts across A and B and figuring out what the total current is that would be coming into this. And then we want to figure out what the current is in just this 12 ohm resistor in the center. So for part A, we can do this in a couple of steps. And basically the idea with anything like this is to identify combinations of resistors that you know what to do with to find an equivalent resistance, combine them into an equivalent resistance, and then sort of iterate through that process until you get an equivalent resistance. And you can't always use just series and parallel combinations for every possible way of connecting resistors together. But in this case we can, and so we don't need to get into anything too terribly complicated. So first, note that these two 6 ohm resistors are in series with one another. Any current that flows into this 6 ohm resistor flows out of it, and then also flows into this 6 ohm resistor and out of it. And since there's nowhere else for the current to go, they're in series. And then similarly for these two 6 ohm resistors. Now, resistances in series add, so we have a 12 ohm equivalent resistance here, which we can draw. The empty box type of symbol for resistors is easier to draw, and is also easier to see in to make out where resistors are in complicated circuit diagrams, and is the standard used in some parts of the world. So that's why I prefer it. Not necessarily because other parts of the world use it, but because it's easier to draw and easier to see. So now we have 3 12 ohm resistors in parallel. We see that the voltage across each of our resistors, the 2 of them are equivalent resistances, is always going to be the same, because so they're in parallel. Now if we have 3 resistances in, well, these 3 resistances in parallel, we can just use the formula, because they're all the same, it makes it fairly easy. 1 over the equivalent resistance is equal to the sum of 1 over the individual resistances. And since they're all the same, we just get a multiple of 1 over 12 ohms. So that's 1 over 4 ohms. And we can see that the equivalent resistance then is 4 ohms. You can see from this that if you had n resistors in parallel, all with identical values, that you just end up getting an equivalent resistance of 1 over n times the number of identical resistors you have. But that's sort of just a little bit of an aside. Now we can use Ohm's law. The voltage across a resistor is equal to the current through it times its resistance. So current is equal to voltage divided by resistance. Now in this case, we have 24 volts divided by 4 ohms. And so this results in a current of 6 amps. Now for part C here, we can note that this 12 ohm resistor is one branch in this parallel circuit, and if all branches of the parallel circuit are identical, we can imagine that for a circuit with 3 branches, each branch is going to get 1/3 of the current. We can also note, however, that there's 24 volts across the 12 ohm resistor, and just directly use Ohm's law and get the same answer, but this is a little bit of a longer way of doing it, but sometimes the longer but straightforward way is all right. So in either event, we either get 1/3 of 6 or 24 divided by 12, which in either case is 2 amps through this single resistor here. And then similarly, the 6 ohm resistors will each have 2 amps going through them. There's 2 amps going through the middle one here, and then each of these have 2 amps going through them, because the 2 amps that goes into this one has to go through this one. And then similarly for the bottom pair here.